All right, everybody, we are going to continue looking at serialism. What we're really going to get into now, we've seen the ways that we can have lines that are related by inversion, and we know about the four different orders that we're going to run into: prime, inversion, retrograde, I did them in sort of a weird order, and retrograde inversion. Now we're going to find how we can actually access all of these, because right now it sort of seems like they just kind of live in outer space a little bit, but we're going to find these a really convenient way for us to just look in front of us and know all the musical material that we could use in a piece, which is super convenient. Think about it just the way that a painter, when they're going to paint, they don't start painting and then realize, oh man, I need that yellow paint. Let me go into the other room, right? We sort of have that image of a painter who has the entire color palette in front of them, so that whatever colors they want to choose, they're ready to go right with that. And that's sort of what we're going to try to build for ourselves now. So let's get a little bit into this and see how we can access all of these different transformations of the row. Remember, we've talked a little bit about what a row is, right? With the other word for a row in serialism is series, right? And that's the musical line which contains one of all the notes that is the foundation for everything in our serialist composition. And what we're going to find is that we sort of need to build that palette, that color palette, or in our case, sort of a palette which has all the orders that we could use. We need to build that, and we're going to do that by building what's called a matrix, which, again, sounds crazy, sounds wild. Again, it's a different way of doing something so that we can get different results. And we're going to build a matrix. Keanu Reeves will be invited. And so to get started, we need to take our initial statement. So not surprisingly, here we're using our Schoenberg row. So again, this is the row. Right, we remember that. So it's 2, 1, 9, 9, 9, 10, 5, 3, 4, 4, 4, 0, 8, 7, 6, 6, 11, 11. Right, 11, 11 is kind of hard to sing. That's why we use our fixed do. Re, do, la, 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 si, fa, mi, 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 do, la. Right, that's why we do it that way. So here's our statement. Now, to get this into matrix mode, we need to make sure that we get our row, get our series, and take it to 0. And when I say take it to 0, I mean make sure that the first number, the first note, is 0. In this case, right now, our first note is 2, which is D natural. We need to get this series to a place where its first note is 0, C natural. And part of that should make sense, right? When we talked about our inversions, right? We did all of our inversions around the axis of 0, around C natural being the axis. So to build our matrix with all of our possible rows, including our inversion rows, we need to get it so that it starts on 0. So in this case, remember, we do everything clockwise. So to get from 2 to 0, we need to go around 10. Now, I'm going to give you a little secret. Don't tell anybody. This is sort of just between us. Sometimes you can just subtract 2 to get from 2 to 0. But don't tell anybody. So if we took this and moved it so that the first note was 0 by transposing everything plus 10 or minus 2, we would get this line. 0, 11, 7, 7, 8, 3, 1, 2, 2, 2, 10, 6, 5, 4, 4, 9, 9, right? Or do, si, sol, 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 la, mi, re, 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 si. What's this note? I'll call it fa, right? So we've got this same line, right? Because remember, the intervals are the same. It's just a statement on a different note. This is another version of the prime row, right? Because our prime row that we started with started on 2, was re, do, la, 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 si, fa, mi, right? But here we're starting on 0, but it's still the same line. It's do, si, sol, la, mi, re, right? It's still that same prime row. It just starts in a different place. Just the same way that I could do this starting on D, and then I could do this starting on C, and we would easily say, yeah, it's the same line, it's just starting in a different place. So we transposed from the first spelling starting on 2 or starting on D natural, and we moved it to C. And that's going to be very important because once we get it to 0, we are ready to start building our matrix. Oh my goodness, and there it is. This is our starting point. So we can see that up on the top line here, we've got our prime order, right? 0, 11, 7, 3, 1, 2, 2, 2, 10, 6, right? 5, 4, 4, 9, 9, right? There's our line. Again, that should be just burned in our brains by now. So that's what's on the top there, our prime order. So what do you think it is over on the left going top to bottom? What kind of order is that? Well, let's find out. We've got 0 in the corner, so that's, top left corner, that's the same. But instead of going 0, 11, going from top to bottom, we go 0 to 1. Why do you think there's a 1 there? How does the number 1 or the note 1, how does that relate to the note/number 11? Are 1 and 11 a pair of notes in our Mod 12 system that are paired together in an interesting way? Do they maybe add to 12? Oh my goodness, yeah, because look, it's the inversion of 11. 0 to 11, the inversion is 0 to 1, right? Let's see, what about the next one? So we've looked at 0, 11 and compared it to 0 to 1. What about now? The next one is 7. So we've got our 0, 11, 7. What do we think? What's the inversion of the note 7, G natural? 7 plus what equals 12? Oh, 7 plus 5 equals 12. And what do you know? Our third number down is 5. And we can see if we do this going the prime order, 0, 11, 7, right? We go down basically by a fourth from 0 to 7. If we do the inversion, 0, 1, 5, we end up on the note F natural, 5. C to F is a fourth. This is the inversion. See how it's the same melody, just inverted, just the opposite direction. All the intervals are reversed directionally. So this whole left-hand column here is the inversion of our prime order. So here's the first little bit of our prime order. And now, what are we going to get in the inversion? Right? See how it's kind of got that same thing. Now, when I play with the same rhythm, it obviously has, even more of a connection. But that's a really interesting thing. So now we've got our prime order on top, our inversion down the left-hand column, all the way down. And if you sort of compared number to number all the way, you would see that it fits. And we could just test this by going to the very end. The last number in our prime order is 9. 9 is A natural. What's the inversion of 9? It's 3, which is E flat or D sharp. And what do you know? Our inversion order ends with 3. So we can check that worked. Now we got to do what the next steps are, which is to just fill out the rest of this matrix. And this is done in not at all a complicated way. So I'm just going to show you how to do the next couple. So we're coming in here into edit mode. So we have our prime order, 0, starting 0, 11, 7, right? Right. The way to just build this up is to just go one by one. This is really, really straightforward. It actually, I think, seems like it should be more complicated than this, but it's not. So since our prime order started on 0, what we're going to do is we're now going to build the prime order starting on the next number up, which is 1. So I'm going into this second line here, and we can see it starts on 1. And what I'm going to do is just add 1 to each of my prime numbers. So in the prime order, it goes 0, 11. But in my order starting on 1, my prime order starting on 1, I'm going to go 1, 0. 7 plus 1 is 8. 8 plus 1 is 9. So now let's check these first 4. This was the prime order, 0, 11, 7, 8. Now let's check what I have so far on 1. 1, 0, 8, 9. Here's back on 0. See how it's the same musical idea, just a half step up? So here we go. We got 4. What's 1 plus 1? 2. Very good, everybody. Add 1 to this is 3. We get 11. This one should be 7. Then we get 6. Then we get 5. And then we end on 10. Now, how do you think what's one way we could check to make sure we've done it right? It would be to make sure that we only have 1 of each of the notes. We've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if I was going through, and let's say I did something wrong here. I'm going to change this to a 4. Let's say I was going through, and I didn't find a 3. So I got 0. I got 1. I got 2. Where's 3? Uh-oh, there's no 3. That would mean that I had done it incorrectly. And I can also see that the fact that I have 2 4s, because remember, in each series, you get 1 of each note. So if you go through and realize, oh man, I have 2 4s in here, that means it didn't go the way you wanted it to. All right, so I did the row based on 1. Which row do you think I do next? Do I just now go to the next one and say, okay, now I'll add 4 to each of these? Well, that's one approach. My approach is to say, you know what? I did really well going from 0 to 1. Why don't I now go from 1 to 2? So I'm going to go downwards and find here's the row that starts on 2. And now I'm going to just continue adding 1 from the 1 line. So this was 0, now it's 1. This was 8, now it's 9. This was 9, now it's 10. This was 4, 5. You see what I'm saying here? This one, since it's 3 here, is going to be 4. This was 11. So what's 1 up from 11? This is sort of strange. It's not 12, it's 0. Here's 8. Next one should be 7. Next one should be 6. And then the next one should be 11. And again, I can go through, make sure I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I can play it 2, 1, 9, 9, 9, 10, 5, 3, 4, 4, 4, 0, 8, 7, 6, 11, right? To check it, let me do one more together. I'm going to go from 2 to the 3 line, adding 1 to each. 2 should be 10, should be 11, 6, 4. This is 5. This is 0 plus 1, 9, 8. Here's 7, and here's 0, because 11 plus 1 in this world is 0. All right, so what I want you to do is continue building the rest of this matrix, and then we will touch base when we're done with that. All right, thanks, everybody.